Welcome to KT Study Zone. In this video series, we are talking about motion in a straight line. This is part 2 and we're going to talk about motion graphs. Alright, let's see what are the objectives of this lesson. First one, to draw a graph using given data and to recognize a graph using its axis. Importantly, to solve problems using a given graph. Well, before directly jumping into motion graphs, let's get a general idea of graphs. Well, y-axis and x-axis can be directly read by the graph itself. If we talk about the gradient, it is the slope or the inclination of the line drawn in the graph. It indicates the ratio of change in y-axis to the change in x-axis. So, the formula is y-coordinate difference divided by the x-coordinate difference, which is delta y divided by delta x. Well, the area under the graph can have a meaning depending on the considered graph. It can be calculated using the geometric formulas of the shapes shown in the graph. In this case, it's a triangle. Let's start with displacement time graphs. A graph that illustrates how displacement of a body varies with time is a displacement time graph. Directly from the x-axis, time is indicated, and directly from the y-axis, displacement is indicated. Gradient of a displacement time graph gives velocity. Area doesn't give anything. Three types of motion can be identified using displacement time graphs. First one is stationary phase or at rest. It is shown as here. Well, in here, the gradient or the slope is 0. Well, the second one is uniform velocity. Well, in this case, gradient is not 0, but the gradient is constant. Well, there is clearly an inclination in the line of the graph. If the line of the graph is climbing up or it makes an acute angle with the x-axis, the movement is in the positive direction. But if the line is falling down or make an obtuse angle with the x-axis, then the movement is in the negative direction. The third one is acceleration or deceleration. In the case of acceleration, the gradient or the slope of the graph increases with time. The first picture shows acceleration in the positive direction and the second picture shows acceleration in the negative direction. Well, in the case of deceleration, the gradient of the graph or the slope gradually decreases with time. In the third picture, it shows deceleration in the positive direction and the fourth picture shows deceleration in the negative direction. Let's get into example questions. First one, draw a graph based on the following table. So they have given time and displacement. What you have to do is first draw x-axis and y-axis. X-axis is time and displacement is y-axis. Don't forget to mention the units of each physical quantity. So first, mark each coordinates. Time from 0 to 8 and displacement from 0 to 20. And then by considering displacement at each second, you have to mark the points and match them. Then you will get the relevant graph. Next they ask, explain the motion. Well, the object starts from rest. Why? Because the gradient at start is 0. Moves 20 meters with a uniform velocity. Why? Because the gradient is constant in first 4 seconds. Don't forget to state the time in each incident. Stays at rest in next 2 seconds. Why? Again because the gradient becomes 0. Turns back and moves 20 meters with a uniform velocity to starting point in last 2 seconds. So, You can see the object had started a motion, moved a certain distance and turned back, and again it has come to its original position. So you just have to look at the graph and explain its motion. How far the object has moved after starting from rest. So you can directly see that it's 20 meters. Next they ask, how long has it taken to travel the above distance? You can also see that directly through the graph, it's 4 seconds. Next, find the maximum velocity of the object during first 4 seconds. So how to calculate the velocity in a displacement time graph? You just have to calculate the gradient, which is 20 meters divided by 4 seconds, and the answer is 5 meters per second. Next, what can you say about the motion during the interval from 4 seconds to 6 seconds? Easy, right? It's at rest, remains stationary, because the gradient is 0. Next, find the maximum velocity of the object during last 2 seconds. You again have to calculate the gradient, which is 20 meters divided by 2 seconds. The answer is 10 meters per second. Okay, now let's see about velocity time graph. Well, graphs that illustrate how velocity of a body varies with time are velocity time graphs. Directly from the x-axis of a velocity time graph, time is indicated, and directly from the y-axis, velocity is indicated. The gradient of a velocity time graph gives you acceleration, and the area gives you displacement of the object. 3 types of motion can be identified in a velocity time graph. First one is stationary phase or at rest. In this case, y-coordinate is 0. Second one is uniform velocity. In this case, the y-coordinate takes a constant value, or we can say the gradient is 0. Third one is acceleration or deceleration. In the case of acceleration, the gradient is increasing, and in the case of deceleration, the gradient is decreasing. Let's get into example questions. Draw a graph based on following table. So they have given values for velocity and time. What you have to do is first draw the x-axis, which is time, and y-axis, which is velocity. Don't forget to put the units. So first what you have to do is mark the coordinates. Time from 0 to 8 and velocity also here from 0 to 8. Then what you have to do is to mark velocity values at each second. Then you have to match them. Then you will get the graph. Next they ask to explain the motion. Well, the object starts from rest. Why? Because the gradient is 0. Uniformly accelerates. Why? Because the gradient is constant. Gains 8 meters per second velocity within first 4 seconds. Maintains that 8 meters per second constant velocity in next 2 seconds. And uniformly decelerates and come to rest in last 2 seconds. So the object has accelerated, maintained a constant velocity, and then decelerated and comes to rest. So you just have to look at the graph and explain it. Next they ask, find acceleration of the object during first 4 seconds. So how to calculate the acceleration in a velocity time graph? You just have to calculate the gradient, which is 8 meters per second divided by 4 seconds. The answer is 2 meters per square second. Then, find the distance traveled by the object during first 4 seconds. So how to calculate the distance in a velocity time graph? You just have to calculate the area. In the first 4 seconds, it's a triangular shape. So, half into 8 meters per second into 4 seconds is 16 meters. Then, find the maximum velocity reached by the object. It is 8 meters per second. You just can get it directly from the graph. Then they ask, What is the distance traveled at a uniform velocity? That means from 4 seconds to 6 seconds. So you can see the shape is a triangular shape. So how to calculate the area? 8 meters per second into 2 seconds. Again it's 16 meters. Then find the deceleration during last 2 seconds. You have to calculate the gradient here, which is 8 meters per second divided by 2 seconds, and the answer is 4 meters per square second. Finally, they ask, find the distance traveled during last 2 seconds. So again, it's a distance, you have to calculate the area, and in the last 2 seconds, it's a triangular shape again. So half into 8 meters per second into 2 seconds is 8 meters. Easy, right? Next, I discuss acceleration time graphs. This is not in the O-level syllabus, but the discussion is worth it. Well, a graph which illustrates how acceleration of a body varies with time is an acceleration time graph. Directly from the x-axis, time is indicated. Directly from the y-axis, acceleration is indicated. Gradient doesn't give any meaning, and the area gives the change in velocity. Motions that can be identified are at rest or uniform velocity. Both are shown in the same way as shown in this picture. Second one is uniform acceleration. It is shown as in this graph. Well, the gradient is 0. That's it. Hope we clarified all your questions about motion graphs. What you have to do is practice more questions and subscribe.